So far we've talked about expressions and equations, but in this video we're finally going to get to inequalities, which is just like a mathematical sentence, but instead of an equal sign, it's got one of these symbols, and these should be pretty familiar to you. So you've got greater than, less than. This one's greater than or equal to, and then less than or equal to. The way I like to remember these is basically it just always, like, if this is like a mouth, it always eats the bigger thing. It makes sense, right? Like the bigger side is going to go with the bigger quantity, and the smaller side is going to go with the smaller quantity. Think of it like an alligator. Obviously, it's going to eat the bigger pizza than the smaller pizza. That is pizza, right? Yes, I think so. Also for you music people, if you think about, like, if you see a symbol that looks like this, it's like a crescendo. It's going from softer music to louder music. Whereas like if you have this, it would be like louder to softer music. So same idea. So here's kind of some general steps for solving inequalities. Basically, everything is the same as if you were solving a regular equation. Like you're going to try to combine the variables and just get the variable by itself. But the only difference is there are two occasions when you're going to need to flip the inequality sign. One of those is if you just flip the whole inequality, you would have to flip the sign with it. So if you ever like swap the two sides for whatever reason, you need to flip the sign too. And the other time you need to flip the inequality sign is if you ever multiply or divide by a negative. That is the only time you need to flip the inequality sign. So we're going to go through a few examples. Let's see here. All right, so the first one, before we actually make it an inequality, let's think about just this equation right here. If I were going to solve this equation, I would want to get x by itself. So I would divide by 3, and then x would be 2. If I wanted to like graph that on a number line, here's a number line. The number line has all the numbers on it. We can label a few of them, but it goes forever. X equals 2 is literally like here. There it is at 2. Now let's see what happens if I make this an inequality. So instead, what if it were 3x is greater than 6 instead of being equal to 6? So I will still just divide both sides by 3, just like we did before. And so in this case, x is greater than 2. If I wanted to graph this, basically what this is saying is I want, 1, 2, 3, -1. I want to graph on the number line any value that is greater than 2, because I want anything that is bigger than 2. So that includes 3, and it includes 4, and it includes 5, it includes 2.1, it includes all of this. Let me use a different color. It includes all of this, but it doesn't include 2. 2 is not greater than 2. And so to say we're not going to include 2, what you're going to do is draw an open circle at 2. So an open circle at 2, draw your arrow this way, kind of shade this way. I'm going to include everything that's bigger than 2, but not exactly 2. So if you ever use an open circle, that means it's not included. That endpoint is not included. If you ever use a closed dot right on the point, that means that it is included. So for example, say instead of just greater than, this had been greater than or equal to. So this would be greater than or equal to. And since it could possibly equal to, that would be a closed dot. Just to compare the two, this one only had one solution, because the only thing that would make this work is literally a 2. 3 times 2 is 6, and there's nothing else that works. This one, lots of things would work. Anything that's bigger than 2 would make this equation true. If I plugged in a 3, 3 times 3 is 9, which is bigger than 6. If I plugged in 100, 3 times 100 is definitely bigger than 6. But if I plug in a 1, 3 times 1 is not bigger than 6. So this stuff doesn't work, this stuff does. There are infinite solutions. Okay, so the solution was this, and if you were asked to graph it on a number line, it would look like this. Let's try another one. Again, just like before, we're just trying to solve for x. So I'm going to divide by -3 since we were multiplying, and divide by -3 and get x by itself. This one you have to be careful though. This is an example of dividing by a negative. And remember, if you ever multiply or divide by a negative, you have to flip the inequality sign. So instead of less than, it's now greater than -4. So that's my solution, anything bigger than -4. And so if I want to graph the result on a number line, I'm going to go to -4. You can put other numbers too, but really only need the -4. And so on. And since it doesn't equal -4, I'll do an open circle. And then I want everything greater than -4. That means stuff bigger than -4, stuff this direction. Here's a tip for these graphs, because these can be a little confusing. If you have the variable on the left side, which we typically do, we typically have the variable over here, then the inequality sign points in the direction that you're going to shade your graph. See, like imagine this were like an arrow. So I shade that way. If it were less than, I would shade that way. That only works though if the variable is on the left. Let's try another one. Let's do 4x plus 2 minus 7x is greater than 2 plus x plus 8. So before I get started on this one, I need to combine some like terms, just like we have been doing. So 4x minus 7x is -3x plus 2, and that's greater than 2 plus 8 is 10 plus a bonus x. Now as I am trying to solve, I notice I have some variables over here and over here, and I need to get them on the same side. You could subtract x and move it over here, or you could add 3x and move it over here. Either way, I'm going to try to keep it positive, so add 3x to both sides, so that I'm left with 2 is greater than 10, and 3x plus 1x is 4x. Now I've got all my x's combined, and so I'll just move everything away from the x until I've got it. Subtract 10, and then divide by 4. So -2 is greater than x. This is the answer, but it looks a little nicer, like I mentioned before, if you have the variable on the left-hand side. So if you want to rewrite this and flip the entire thing, it would be x, and x is supposed to be on the smaller side, -2 is on the bigger side, so you basically have to flip the sign. So x is less than -2. Either of these are fine. I'm going to go with this though. And then if I graph it, here's -2. It's not equal to -2, it's just, it gets right up next to it. And then it's anything less than -2, stuff that's smaller than -2, which would be things like -3 and -4. It goes in this direction. Also remember, as long as I have that x over here, this points as an arrow to shade that way. That wouldn't work if I was just doing this though, that's kind of why I flipped it. Okay, let's try some fractions now. There's a few ways you can handle fractions. My personal favorite is just to not deal with fractions by getting rid of them. So if I want to get rid of dividing by 3, dividing by 2, and dividing by 4, I could multiply everything by a 3, and by a 2, and by a 4, but there's an easier way, which is just multiply everything by their least common multiple, 12. Because if I multiply this by a 12, it'll cancel, and if I multiply this by a 12, I can divide that evenly, and if I multiply this by a 12, I can divide that evenly. So as long as you do the same thing to both sides of the equation, or in this case, an inequality, it's a legal move. So 12 times 1 divided by 3 is 4. 12 times 1 divided by 2 is 6. And 12 divided by 4 is 3. So 3x. Okay, now I got rid of all the fractions, but I still have x's over here and x's over here, and I need to get them on the same side. You could move 4x over here or 3x over there. Again, it doesn't matter. If you move 3x, I want to show you what happens. That's fine. We'll keep it positive and do 4 minus 3 is 1x. But what's left on this side? I had 3x, I took 3x away. So it's not nothing, it's a 0. 0 is a number. So just leave a 0 there, kind of as a placeholder. And to get x by itself, just add 6. So x is less than or equal to 6. If I were to graph that, here's 6. In this case, it would be a closed dot because it could equal 6. So it might literally hit 6. Or it could be anything less than 6. It points that direction. So I'm going to shade that way. Sorry for my horrible arrow. If you'd done the other way, if you'd subtracted the 4x instead, you'd get negative x is less than or equal to, or sorry, negative 6 is less than or equal to negative x. And then to get rid of the negative, you'd have to divide by a negative 1 or multiply by a negative 1. When you do that, it flips the sign. So it would now be greater than or equal to 6. And so I have 6 is greater than or equal to x, which is the same thing as x is less than or equal to 6. Just flip this, and you would get that answer. Okay. Let's do another one. All right, here's our last one we'll work out. All right, so this one has 2 different variables, an x and a y. We're going to first solve for y and then solve for x. So to solve for y, I'm going to have to get y by itself. So that means subtract the 4x. You're left with negative 2y is greater than or equal to 6 minus 6x. Then divide by the negative 2. Divide all this by the negative 2. Be careful, you just divided by a negative, so that flips the sign. 6 over negative 2 is negative 3, and negative 6 over negative 2 is positive 3. And so that would be my answer if I were solving for y. You wouldn't be able to graph this on a number line, it'd have to be a full coordinate grid, so we're just going to leave it there. Imagine instead that I were trying to solve for x. If you were working on this, they would tell you which one to solve for. They'd either say solve for y or solve for x. So I'm going to write it out again. If I'm trying to solve for x, I've got x's over here and x's over here, and I got to get them on the same side. So I'm going to add 2x to both sides, so that now I have 6x minus 2y is greater than or equal to 6. And now all my x's are combined. I still need to get x by itself, so add 2y to both sides. And then divide by 6. So there we have it. x is greater than or equal to this. You can simplify this a bit if you want. 6 over 6 is 1. 2 over 6 is a third, so a third y, or y over 3, either way. That's a more simplified answer. So these look different, right? If I solve it for x versus if I solve it for y. Just depends on what the problem asks for. Just to show you one final example, maybe they might give you an inequality and you have to write an equation for it. So this is 5 and that's 0, so 1, 2, 3, that's a 3 right there. So I would just say x is greater than 3. And that's it. Because it hits at 3, but, well, it doesn't exactly hit at 3. It gets all the way up to it, but it's an open circle, meaning it doesn't actually equal 3, it's just greater than 3. And see, all these numbers are bigger than 3. It's 4 and 5 and 6. Those are all bigger than the 3, or like the arrow points that direction. So that's inequalities.